Today we're going to graph radical equations. So let's look at the graphs of some functions and figure out what the domain is and how the graph makes sense. And also find the range. So if we look at a square root function, like y equals the square root of x. Okay, so we're going to start by making an xy chart. So first we need to figure out what the domain of this is going to be. So we know that when you have a square root, you can't have a negative inside of the radical. If we have a negative inside of the radical, it makes it imaginary. So what we're going to do is we're going to take whatever is inside the radical and we're going to make it greater than or equal to 0. So since x is just x and there's nothing else to solve for, that's our domain. So the domain is anything that's greater than or equal to 0. So if x was 0, the square root of 0 is a number. Anything higher than 0 will work. If I put in a -1, it's not going to work. It's not within our domain. So when I plug in my values for my xy chart, I'm always going to start with my domain. Since 0 is the lowest value x can be, I'm going to start with that. If I plug in 0, the square root of 0 is 0. Okay, then I'm going to pick a value greater than 0. So I'm going to pick 1. Square root of 1 is 1. Okay. If I go to 2, square root of 2 is not a whole number. So what I want to do is I want to pick x values that's going to make my y value be a whole number. So I'm going to jump to 4, because if I use 2 or 3, it's not going to give me a whole number for y. So now the square root of 4 is 2. And then I'm going to plug in another one, and I'm going to jump to 9. So the square root of 9 is 3. If I go to graph this, here's I'm at 0, 0, 1, 1, 4, 2, and 9, 3. So the function kind of looks like a hook. Okay, it's going to start at 0, 0, and it's going up towards the right. It's not going to go into any quadrant that's on the left side. Okay, because we said that we can't have negatives. So the square root of the numbers are going to be positives. They're going to stay to the right. So the domain for this, we're always looking at the first point. So the domain is what we solve for. The range is going to be the resulting y. So my domain for this is going to be x is greater than or equal to 0. And then the range is going to be y is greater than or equal to 0. Since my y value was 0 when my domain was 0. If I wanted to graph the negative radical x, I'm going to do this in green. Okay, I'm going to make another xy chart. So now what I'm doing is I'm doing negative, y equals negative radical x. So I'm going to do the same thing for the domain. I'm going to take what is under the radical, which is x, and I'm making it greater than or equal to 0. So I'm going to plug in 0 for x, and then I'm doing negative radical 0, which is 0. Okay, again, I need to pick some values for x. So if I pick 1, the square root of 1 is 1, but I'm doing negative radical 1. So that's going to end up being negative 1. Okay, x is 4, so that's going to end up being negative 2, because it's negative radical 4. And then 9 is going to be negative 3. So if we look at the graph of this one, it's starting at 0, 0 like the other one. I have 1, negative 1. I have 4, negative 2, and 9, negative 3. So if we look at this piece, it's also a hook, but it's going the other way. Okay, it's a reflection of the other one. So our domain here is going to be x is greater than or equal to 0, and the range, in this case, is going to be y is less than or equal to 0, since it's going underneath. So now the red graph is going up, so the y values are greater than the lowest y value. In the green one, it's going down, so the y values are going to be less than the highest y value. And if you look at this picture together as a whole, the red and the green together, that makes a sideways parabola. Since a parabola is an x squared function, when I take the square root of it, I get plus or minus. So the plus would be the red, and the minus part would be the green. When we graph radical functions that are square roots, we're graphing them as a piece instead of as a whole. So we're not doing the plus and minus version, we're just doing whatever version they tell us. So whether it's the positive square root of x or the negative square root of x, we're not going to ever graph plus or minus square root of x. It's going to be one or the other. So let's look at another example. So we want to find the domain and use the table of values to graph the function, and then find the range. So again, the domain, we're going to take whatever's underneath the radical, so x, and we're going to make it greater than or equal to 0. So we don't have to solve anything, it's already solved. So we'll make an xy chart. So we're going to start with that x value, which is 0. If we plug it in, we're going to do the square root of 0 minus 2. So that's going to be negative 2. Again, we want our x, or we want what's underneath the radical to be a perfect square, so that way we can take the square root of it and get a whole number. So I'm going to use 1. So the square root of 1 minus 2 is going to be negative 1. I'm going to jump to 4. So the square root of 4 minus 2 is going to be 0. I'm going to jump to 9. So square root of 9 minus 2 is going to be 3. So then we're going to graph this. So I have 0, negative 2 is where it's starting. 1, negative 1. 4, 0. And then 9, 1. And there's my graph. And now my domain and my range, I'm looking at that first point. So the domain is going to be x is greater than or equal to 0. So that's whatever we solved for in this piece. And then since the graph is going up, my range is going to be y is greater than or equal to. And we look at the y value, which at that point is negative 2. Now when we look at this one, we have more underneath the radical than just the x. So same idea though, we're going to take whatever's under the radical, so in this case x plus 1, and we're going to make it greater than or equal to 0. But now we have to actually solve for x. So we're going to minus 1, so x is greater than or equal to negative 1. So that's going to be the point that we start at. So when we make our xy chart, we're going to start with a negative 1 for x. So when we plug that in, we have negative 1 plus 1, so it's the square root of 0, which is 0. Now, we also want to make sure that what's underneath the radical is a perfect square. So we have to figure out what x needs to be. So when x was negative 1, underneath the radical was 0. So I'm going to over here, just kind of. So x plus 1 equals 0, right? We solved that and we got negative 1. So now we want x plus 1 to equal 1, because 1's a perfect square. So if x plus 1 equals 1, just solve that, and then x is going to be 0. So when x is 0, 0 plus 1 is 1, square root of 1 is 1. Then we have the next perfect square, which is 4. So we're going to do x plus 1 equals 4. So what does x have to be in order for x plus 1 to equal 4? That's going to be 3. So then we're going to do the square root of 3 plus 1. So the square root of 4 is 2. 2 comes out. And then we'll do x plus 1 equals 9. So x plus 1 equals 9. That means that x has to be 8. So then we're going to do the square root of 8 plus 1, which is the square root of 9, which is 3. So in order to just make this a little bit easier, you want to set the radicand equal to 0, 1, 4, and 9. Because you want what's under the radical to be a perfect square, so that way you can simplify it easy. And you need 4 points when you're graphing these. So 0, 1, 4, and 9 are obviously the lowest perfect squares, so we're just going to use those. So now we're going to graph -1 and 0, 0, 1, 3, 2, and 8, 3. Okay, so all of these are going to have the same shape. They're all shaped like a little hook. Now we want to find the domain and the range, and remember that that's off of that first point. So the domain is going to be x is greater than or equal to -1. So it's whatever we solved for initially. And then the range, since it's going up, it's going to be y is greater than or equal to the y value, which is 0 at that point. Okay, so what about cubic root functions? What's the domain and what's the range? So if we look at a cubic, y equals the cubed root of x. Let's make an xy chart. Now, the thing with cube roots is that you can have negatives inside the radical, right? So when you're having an even index, you have the imaginary, so you can't have negatives inside. But when you have an odd index, you can have negatives inside. So you want perfect cubes. So let's use -8, -1, 0, 1, and 8. Okay, so these are the key cubic roots or perfect cubes to think about. So the cubed root of -8 is -2. The cubed root of -1 is -1. The cubed root of 0 is 0. Cubed root of 1 is 1. Cubed root of 8 is 2. So when we go to graph this, we have -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. So if we follow this shape, it kind of looks like an S. And in this case, since it's going on forever in both directions, your domain and your range is all real numbers. So there's nothing that x can't be. There's nothing that x can't be, since x can be positives or negatives. And then in that case, the y can be anything as well.